Hello everyone, I am Saptarshi Mukherjee. I am a software engineer 3 at Google and I've been a competitive programmer for quite some time. So in this playlist we are going to discuss all the problems of this contest Codeforces round 923, and in this video I'm going to discuss the first problem, make it white. So let's get started. The first step, let's understand what the problem is. So you have n cells, a strip of n cells, each cell is either white or black. You can choose a continuous segment of cells once and paint them all white. So the black in that segment will become white, and whatever are already white, that will remain white. So it's something like this. Let's take this example. WBB, WBW. As I told you, the second step of every problem is understand the test cases. See if you understand them well. WBB, WBW, WBB, WBW. You have to convert the black ones to white. I think that's what the question is. Minimum length of the segment for all the n cells to become white. All the n cells should become white. So let us see. All of them needs to be converted to white. So these four you have to focus, these three you have to focus on. You have to convert them to white. So what can we say? You can choose the entire segment to paint them white, or you can say this particular segment can be painted white. If you paint the segment white, then everything will become white. This will be converted to white. This is already white. And the ones outside the window, they are already white. You need to choose the segment of the minimum size. So this size has to be minimum, the size of this segment. That's it. So how to solve this problem now? For this problem, I won't look at the constraints. Why? Because we have to reach each element. So it has to be at least linear. It can't be better than linear. You have to read each element. And the strategy is very clear from here. I don't have to read the constraints. It cannot be better than big O n. And if we have a big O n approach, then we don't need to see the constraints. So in this case, I can say, hey, if I have to paint a certain window, I'll choose that window which includes all the B elements. So if I know that this is the leftmost B and this is the rightmost B, and there are some elements here, there are some elements here, all of these are white, all of these are white, I can say, hey, pick up that window which has all the B's. So from the leftmost B to the rightmost B, there can be other B's as well over here, other W's as well over here. But this is that window which will say that yes, I have all the B's, and you cannot find a smaller window than me because I'm including the two extreme B's at my terminals. So definitely you can't get a bigger window. So if I say this much that hey, this is the smallest window, the answer is 4. I think the minimum length has been asked. So the answer is 4. We can take another example as well, this one. You can see that from the leftmost B to the rightmost B, which includes 7 characters, I think, you have the answer as 7. Similarly over here, the leftmost B is at index 2 in 0 indexed manner, it's an index 2. And the last B is at index 5. So from 2 to 5, you have 4 elements, I believe. So yeah, the answer is 4. So if you notice that yes, this is at index L, this is at index R, this is the leftmost B, this is the rightmost B, then the distance, the length from L to R basically is given by R minus L plus 1. This is the length you need to consider. This is the minimum length of the window you need to apply. That's it. If we look at my solution, that's exactly what I have done. For my solutions, you need to go to this function where I keep my main solution. It's called from the main function and those things, of course. So for every test case, this is what I have done. Take the inputs, then go from left to right, and whichever is the first B, break that, and that is your leftmost point, minimum point. And then I'm going from right to left, whichever is the maximum I'm taking that as the maximum, and then it's max minus min plus 1. Do we need 2 different loops? No, one loop is sufficient. Am I computing more? No, because from the left to the first B and from the right to the last B, definitely the whole number of iterations will be less than equal to n. Why am I preferring this method instead of one loop for finding the minimum and maximum? Because I felt this is easy. So these are problems which you like to solve in 1 or 2 minutes, or even lesser than that, actually less than 1 minute. So you choose the thing that is actually occurring as the easiest to you. That's it. Time complexity, definitely big O N. So total time complexity or total time taken depends on the total n. Total n, nothing is given, but n can go up to 10, and there are 10 to the power 4 cases. So 10 to the power 4 into 10, that is 10 to the power 5. Easy, correct answer verdict. That's it. Stay tuned for the next problems, which are far more interesting, far more intriguing. See you all in the next videos. Do like, share, subscribe if you find the videos interesting and informative. They mean a lot to me. So yeah, thanks for all your support, and see you all in the next videos.